Hello and welcome to Pactober 2023. I'm Yusuf Nabi and I'm really pleased to be here to host this event. I'm the community shepherd for Pact and a developer advocate for Pactflow. Just a little bit of housekeeping before we start. We are being recorded. We would really love to encourage participation. So if you are joining the Zoom call, please feel free to turn on your microphone. We're joined by Jo Lang, who's our community manager. She will be attending to all of our questions on YouTube and Zoom in the chat. If there's anything technical, please feel free to shout out or put your hand up or make the hand emoji in the Zoom, and we can reach those questions in real time. If there's anything non-technical, feel free to reach out to Jo and she can help. We do have some various links that will be shared in both YouTube and Zoom. There is a code of conduct, so we will be sharing that as well. So we've got a jam-packed schedule throughout the month, with a number of wonderful speakers such as Sam Newman, JB Rainsberger, and a selection of members from the Pact core team and the Pact community. But without further ado, it's my absolute pleasure to introduce a good distinguished friend of the Pact community. It's Seb Rose with a fantastic talk for you all.
Thanks, Yusuf. So hello, my name's Seb Rose. I worked with both Yusuf and Jo Lang when I was working at SmartBear. This is a talk that I have given a number of times about contract testing. So let me make sure that you can see it. That's all good. So it's called Improving Software Quality with Contract Testing and Pact. I encourage those of you that are on the Zoom call, if you have any questions as I go through, please interrupt. I might not notice it, but I'm sure either Jo or Yusuf will, and they'll interrupt me. My contact details, however, down there in the bottom left of that screen. I'll show them again at the end. I'm really happy to for people to reach out and ask questions at any point after this talk is finished. It's a cheap offer because very few of you ever do. But there you go. Let's see whether anyone gets in touch. So we've got quite a lot to cover in the hour. I will attempt to make sure that there's some time for questions at the end. But here you can sort of see the flow that I'm going through. I want to try and set the scene about what software contracts are. I'd like to talk about how we either deal or don't deal with them in traditional software testing or software development activities. And then I will show how developers might hand roll contract tests if they don't have access, or before, but how they used to hand roll them before Pact existed. Right at the end, I'm going to cover Pact, not in any detail. This is very much an introductory session to let people understand what contract testing is, why it's important, and then to introduce you to what I believe is the best tool in the marketplace to actually make it easy to do. Because by the time we get to Pact and Pact Broker at the end of the talk, you'll have seen quite how onerous it was to do it by hand before Pact existed. So let's start with the introduction. Why do we have contract testing at all? Well, the first problem is that, the world's full of lots of services, microservices, web services, remote procedure calls, you name it. And the consumer frequently has challenges. Oh dear. And that obviously something's happened to my font since the last time I did it. Anyway, the component I depend on isn't ready, is what it's supposed to say in that top right speech bubble. Because you, as a consumer, if you're working with a team in your organization and they're developing a microservice or any service that you are going to need, do you really have to wait until that service is ready and has been deployed? Or would you like to work in a decoupled fashion? Well, it certainly makes software development much more productive and effective if teams can work autonomously. And so the fact that the component you depend on isn't ready should not necessarily act as a blocker for you to continue developing your component that depends on it, if you understand what the contract is. The speech bubble on the left, the component I depend on doesn't provide detailed documentation. This is a common problem. We download things from the internet. They might be open source, they might even be commercial, and the documentation is either non-existent or potentially it does exist, but it's not very pretty. It might not be correct. It might be out of date because documentation, right, doesn't always get kept up to date. And then finally, in the bottom right, one of the consumer challenges is that when a new version of a component ships, are we confident that it's going to behave in exactly the same way? Or maybe even as a nuance there, are we confident that the differences in its behavior are going to be exactly as we've expected, exactly as the producers of that component have advertised? And so these are some of the challenges that exist. And I'm expecting that most of you have experienced one or all of these challenges in your work using open source or paid for components. However, the component creator also faces challenges. So the person who has to write the web service or the microservice or indeed the DLL. They might want to update their component, but they don't know who's using it. So which parts of the interface are really important? Did you instrument them? Is there any way of finding out? You come across a defect in your component and you really want to know, is there anyone that's going to get upset if we fix this defect? Because actually, given enough consumers of your component, even the undocumented features, which includes defects and bugs, someone will be depending on that defect or that bug existing. So just willy-nilly going and fixing a defect, it might feel like a really easy thing to do, or at least a good thing to do, but it might disrupt somebody else's workflow because they've come to depend on it. And finally, when it comes to evolving a component as a provider, especially as a provider of cloud services, do you want to maintain multiple test instances of each component for each version, depending for all your consumers who potentially haven't upgraded yet from the last version? The very end of that sort of thought experiment leads you to an infinite number of versions of your component having to run in the cloud just to support the laggards who refuse to upgrade because the original component did exactly what you wanted. So both the providers and the consumers of a component, of a service, face challenges when they come to their ways of working, and also when it comes to upgrading and updating that component. So what? I mean, I guess is the big question. And the so what here, I'm going to borrow from Beth Scurry, who is one of the original contributors to Pact, and I think you'll be meeting her on Thursday. And she has this lovely, wonderful quote, and it says, if you can't deploy services independently, you don't have microservices. You have a distributed monolith. Now, this is not necessarily a bad thing. Let's be clear about this. Just because you're having a distributed monolith, it doesn't mean it's bad, nor does it necessarily mean it's bad if you have a non-distributed monolith. However, most organizations adopt microservices precisely to get away from this monolith. What they want to do is to have small, independent microservices components that can be evolved and deployed independently. And so we really need to be confident that as our microservices or other components evolve, as we create fix defects in them, add new features, cover new workflows, that we can deploy them independently without disrupting any of our clients' work. And that is a big ask, and it's in fact what Pact really helps with, and as we'll see when we get to the end of this session. So let's think about software contracts to start with. I've tried to say what the problems are without them, but here let's have a look at really dig into what software contracts are. And these are story from a time when I was working for a very large company that you'll all have heard of in 2007. And I was part of a UK product team, and we had to re-platform the product from a bespoke backend service to a new commoditized backend service that was being developed by a platform team in the US. And it was being shipped to us as a Windows DLL. That was fine. We had the DLL, we built our UI and our business logic based upon the interfaces that it provided. And as time developed, the platform team in the US would fix problems and add more interfaces and change bits of the interfaces that existed. And when the new DLL N+1 shipped, we would be often quite frustrated because all of our workflows would break. And no matter how much it seemed like we communicated with the team in the US, this problem still kept happening. They weren't a bad team, but we didn't have a formal way of knowing what was going on in their product. And we weren't their biggest consumer, right? So like I said, it was BigCo, and they were working on a platform. Their platform was to serve everybody within BigCo. And so as a small satellite development organization in Edinburgh, that was problematic. So we couldn't trust the DLL updates. And so I was leading up that team at the time, and I figured that really what I had to do was we had to put every new shipment of the DLL into quarantine and make sure that the areas of its behavior that we depended on either hadn't changed or we understood how they had changed so we could update our software. So we built a test gate, and that test gate was actually just it was like record and playback. I recorded the interactions with the previous DLL, and then I would play those interactions again with the next version of the DLL and expected the same outcome. It worked really well. It was a defensive test suite. It made sure that we knew what changes we would have to make. It made sure that we knew if there were things that had broken that we could talk to the platform team about. But it was quite costly to write and quite costly to maintain. I mean, the reason it was costly was that there are some consequences of having this test gate. Data changes between test runs. It might be a session ID, it might be a timestamp. So when you're comparing traffic over the wire, you've got to be, you can't just be strict about it and fail if anything's different. So then you have to build tooling to ensure that you know which bits to filter out. However, every time we did get a failure, it was a signal that we had to talk to our colleagues in the US to find out whether we'd misunderstood something or whether they'd broken something without intending to, or indeed whether they'd broken something with intending to, but they just hadn't told us that they were going to break it. The outcome was that my product team became much more productive. We never broke that, we didn't stop the development process every time a new DLL got shipped, because we had the test gate, and that was a separate piece of work to ensure that the DLL N+1 was suitable to be released into our development and staging environments. And because the pieces of the behavior of that DLL that we depended on needed to be tested by the test gate, it became clearer what our contract with that DLL was. We didn't attempt to test the whole of that DLL's contract because it was a big piece of work, and they had a lot of functions and features that we didn't need. But we knew what our contract with that DLL was, and the test gate allowed us to identify when there was a divergence between our expectations and what that platform DLL provided. The world since then, so 2007, I don't know, some of you listening maybe weren't developing in 2007, but anyway, since 2007, things have changed massively. If you think of a component X that you're developing, you're probably dependent on classes or modules that ship in the same programming language that you're working in, and probably in other programming languages that you're working in as well. You're probably depending on multiple services in the cloud. You're probably almost certainly depending on some form of data storage. Maybe you're working with databases on a rack, or you're using file system in some way. The world's complicated, right? You're depending on a lot of different things. And although this is a much simplified model, because I'm sure you're depending on many more components than I showed in this diagram, it's too complicated for the purposes of this talk. So what I'm going to think about is not the contracts between all of the components and X, which is what you're working on, but I'm going to think about something much simpler, the interaction between the component or consumer that you are working on and a single provider that you are depending on. And that means that we're only thinking about, certainly for at least the next 20 minutes to half an hour, we're only going to be considering a single contract, the contract between one consumer and one provider. And not very realistic in modern software development, but it'll mean that our brains don't explode just yet. So what? Contracts. There is the interaction between any component and something that it depends on is always governed by some contract. And here, when I say contract here, it is my definition, my working definition here is an agreement between the client and the supplier about who is responsible for what and how the system should behave when people conform to those responsibilities, and what error messages should be communicated when they don't. That's a contract. And by implementing a contract, or at least understanding that there's a contract there and entering into that contract, you should expect some benefits and you will incur some obligations. So we think about your mobile phone contract. When you sign your contract, you're probably signing up for a fixed term, right? So that's an obligation. You're going to have to keep that contract for 12 months, 24 months, whatever. But you expect some benefits, right? You expect the mobile phone company to keep routing calls to you and allowing you to make those calls. So you get something, but you have to pay something. Up in the top right, I've got a picture of a book by Bertrand Meyer. Bertrand Meyer was very influential in object-oriented software fields back in the late 90s and early 2000s. And he wrote this book called Object-Oriented Software Construction, in which he walked through creating a language called Eiffel. And the language called Eiffel is one that you probably haven't heard of. It never really caught on, although it does still exist. But it made contracts a first-class citizen. And I strongly recommend, if you're of the persuasion where you like going and reading about historical activities in computer languages, it's a great book. Take a look at it. Point is, contracts have been around for a long time. Contract testing has been around for a long time. Pact is 10, but Pact is much, much younger than contracts and contract testing. So let's think about traditional software testing. I'm not going to ask you to put up your hands if you tested your software. I really hope you test your software. So the naive approach that some teams, I believe, still work with, and it definitely does work, is that you have a collaboration test, which is a bit like an integration test, or rather, it is an integration test, but integration test is, as JB Rainsberger will talk about in his session later on this week, integration tests leave a somewhat bad taste in the mouth. So I'm talking about a collaboration test where your consumer is collaborating with your provider, governed by the contract, to get some business value. And so the collaboration test between the consumer and the provider, it should be showing us that we're happy to probably release our consumer into an environment where that provider is live. We're going to be testing the contract between the consumer and the provider. We may not be testing it explicitly, as in we're not focusing on the contract, but if the consumer is interacting with the provider and we're depending on the provider to behave in a particular way, then our test requires the provider to work in that way. And therefore, we are, by extension, testing the contract, even if we don't explicitly think of our activity as being a contract test. Now, testing against the provider during development can be really slow. I already mentioned it in the early slide with the speech bubbles. Maybe the provider isn't even ready yet, in which case you can't do that test. But equally, if you want to get fast feedback, possibly you want to run your unit tests as collaboration tests. So you want to run against some version of the provider on your desktop and get feedback as you're developing. Certainly, when you check your code into the first stage of your continuous integration pipeline, you'd ideally like to get your feedback, within a few minutes, so that you don't start working on something else until you know that the last piece of work that you did is working. And so the decoupled approach that most teams that I've worked with adopt is that in the early stages of the CI pipeline, i.e. during development and after check-in. Our consumer is tested by running against a test double. Test double is a word that was introduced by Gerard Meseros in his book, X-Unit Testing Patterns many years ago. And it stands there for mocks, spies, fakes. He has a whole taxonomy of things that you use for doing testing that aren't the actual thing that you are testing against, but sort of substitute for it. And the generic term is test double. And the good thing about this is that you, as the developer of the consumer C, own the test double. The test double doesn't depend on a need for a vast system, for instance, a credit card system running somewhere in the background. So you'll get feedback quickly. And because you own that test double, you can set it up to do things like throw exceptions or timeout or return malformed data. And so you can really test the edge cases of what your component might expect. And then when you get into production, you won't be testing against the test double. You won't be running against the test double. You will, in fact, be running against the actual provider. And what we're looking for is that when we run our collaboration test against the test double, we expect it to pass. And then that should give us sufficient confidence to release that component into production, where we hope it will carry on working in production. That seems great, doesn't it? What could possibly go wrong? This is a slide with a picture from Dr. Strangelove, which is a movie which is somewhat dated now, but I think probably it's a timely reminder for us all to go back and watch it again. But think about it. Have you ever had your unit tests running, okay, possibly even your staging and integration tests in the pipeline running green, and then you ship it to production and uh-oh, doesn't work anymore? Of course you have. That's what could go wrong. Your collaboration test works perfectly in development and maybe in staging, but as soon as you get into production, bang, it goes wrong. The collaboration test is making assumptions about the contract. The test double has been built by you, the developer of the component C, to satisfy those assumptions. When you get a fail, having shipped it into production, what's happened? Well, your test double behaves differently from the provider that it was substituting for, i.e. they do not implement the same contract. And here, this is the problem that we deal with all the time. We need to make sure that our test double stays as a true representation of the provider that it's doubling for. And that is hard work. So what? The test doubles, as we've looked at in the previous few slides, enable isolated testing of your component C, your consumer. This is good because it means that you can move fast, you can move in a decoupled way, your feedback is meaningful, and you can also control edge cases. But the test double that you've built doesn't necessarily behave in the same way as the component that it's doubling for. And this is where the problems crop up. You begin to believe that you begin to gain confidence that your component has been implemented correctly because of the green tests that run against the test double, but then you ship it into production and the tests begin to fail. So you get misplaced confidence, and that's bad, right? Because now you don't know, well, now you begin to layer on more and more manual tests, you get longer and longer test scripts, the road to get your software out there in front of the customer becomes long and hard. So that the use of test doubles can give you a false sense of security. And in fact, that, as we'll see as we go through the rest of the session, that's what contract testing works to help you mitigate. And it's always worth remembering the test doubles are only a model. They're not the actual component. Until you've got your consumer running against all the providers that it depends on, your test doubles are only giving you an approximation of the information that you're looking for. So a quick taxonomy of contracts, a partial taxonomy. I'd like to consider a nut and a bolt. You don't need to be mechanics, but I'm sure you must have screwed a nut and bolt or played with a nut and bolt together. at some point. What's the contract between the nut and the bolt? Just I'm going to pause there and let you think about it. If anyone's in the webinar and wants to chip in, feel free to do so.
The fact that when you attach your bolt to your nut, that it's going to secure whatever it is that you're securing. You're going to trust it when it's tightened up.
So that's an interesting one. That's a higher level expectation. So what I'm thinking about here is that the size of the nut and the size of the bolt are the same, right? So for instance, they're both 10 millimeter nut and 10 millimeter nut and a 10 millimeter bolt. You're also expecting that the thread is at the same pitch. So probably a lot of the people listening to us are familiar with metric pitches, but you can also get imperial and US threads. And if you take a US nut and try it with a European bolt, chances are, even if the hole looks like they're the same size, you'll get it on one turn, it won't go on any further. And finally, threads are left-handed or right-handed. Most nuts go on if you turn them clockwise, but there are some, for instance, that go on lawn mowers and trimmers and things, where the threads are anti-clockwise. So there's an explicit contract that you can test very quickly just by trying to put the nut and the bolt together. Do they fit together? But there are implicit contracts as well. So this actually comes to what Yusuf was just talking about. Are we going to be able to secure two things together? So what we see here, on the left, there's a box with a hole in it. On the right, there's a plate with a hole in it. And what the nut and bolt are trying to do is secure the plate to the box. However, it's never going to work because that bolt is so long that it reaches the other side of the box. And you can tighten that nut up as much as you like, but the bolt head and the nut are never going to come together, and you're never going to be able to fix those two together. That's implicit. It's not even about the thread and the nut. It's about how you are using it, what the context of your usage is. Another example, because you can get bolts with shanks on them. If you're trying to secure two flat pieces together, that shank will prevent that nut from tightening all the way up to the head of the bolt. And therefore, you're never going to be able to press those two sheets together. This, again, is an implicit contract about, I guess here we could be thinking performance. Anyway, the point is that just by looking at the things that are explicit doesn't tell you everything about the contract. There are implicit elements of the contract that most of the tooling that we have today and most of the languages that we use to write software do not surface. And so I'd like to think of contracts as a sort of spectrum from totally implicit, i.e. nobody's told you anything about it, you have to suck it and see, all the way to totally explicit, where somebody's using a computer programming language that surface contracts as a first-class object, or maybe something as mathematical as Z. So Z is probably lives these days mostly in academia, but web endpoints and implicit usage of JavaScript modules, that's at the implicit end, and they're fairly common. And you'll see quite a few different things in here. As you move from left to right, there's more emphasis on correctness and what should happen. And you'll see that Pact is sitting there over towards the right. It's nowhere near as formal as Eiffel or Z, but it does help you get to a place where the contract is explicitly specified in the pacts that you create as a consumer. Another categorization which is useful is, which although I've got it listed vertically, it really goes, it's implicit at the top and explicit at the bottom, is that a lot of components that you maybe pick off off GitHub or from another open source platform, in the actual contract may be informal or absent. You suck it and see, you look at a few examples on Stack Overflow, you use it until a version ships where it stops working, then you have to work out why. And as you move through, you get to something, if you ever get to formal or explicit, you're probably working in a hardened environment, maybe military or engineering, where people have gone to a lot of effort to model and specify the contract. The area that we software development normally sits in is in the middle here, where with unilateral contracts that are partially explicit. And here I'm thinking of several sort of common things. So maybe the HTTP spec, for starters, it's partially explicit. It's got a lot of documentation, it's got a lot of web pages, but there's some undefined behavior, and there are some edge cases where people aren't quite sure what happens. And then we're going to be talking about consumer-driven contracts, which again is partially explicit, and that's the area that Pact sits very, very neatly in, and the area that Pact was designed to work within. So what? All interaction between components is governed by contracts, right? So this is a statement, may be obvious from what we've talked about so far, but it's worth internalizing this. All interaction between components is governed by contracts. If you're saying right now is, but this component doesn't have a contract, that just means you don't know what that contract is, or the contract hasn't been communicated to you. There is a contract. If you do something, if you try and interact with that component in a way that it's not expecting, something will happen. Even that error reporting is part of a contract. The contracts may be explicit, implicit, or more likely a combination of both. So let's move along. Hand rule contract tests. So we were looking at the collaboration tests and the production system in previous slides, where in the collaboration or unit tests, the consumer or component was running against a test double. Then when you shipped it into production, the consumer was running against the actual provider that was deployed in the production environment. A contract test ensures that the test double and the provider behave in the same way for that area of the contract that the contract test was written to exercise. So what am I saying? I'm saying essentially you write one contract test and then you run it against the test double to make sure that the test double behaves in that way. And then you run it against the provider running in production and ensure that the provider also runs in that way. You're trying to make sure that for that area of the contract that you are interested in, the test double and the provider behave exactly the same. And I was introduced to this, what I'm calling here systematic contract testing by J.B. Rainsberg back in 2012. So J.B. was commenting on a mailing list that was that dealt with one of the best books of the early part of this century called Growing Object-Oriented Software Guided by Tests. It's by Nat Price and Steve Freeman. And the mailing list is still there, and people were asking questions about contracts, and JB then articulated very clearly, but not in a very public forum, what his approach to contract testing was. And he said, and I'm pre-saying it here, so please Google that term at the bottom, and it's still sitting there on the Goose mailing list. But he basically said that collaboration tests make assumptions about the contract, and contract tests try to justify those assumptions. So you as a developer of a component, when you make a call, you are making an assumption about how that thing that you're calling is going to behave. That assumption allows you to write a test double to give you the return values that you're expecting. But you need to make sure that those assumptions are true, and you write a contract test that runs against both the test double and the provider to justify your confidence or your belief about those assumptions in the contract. You're going to do it from first principles. Certainly I used to do it in C++. We would write a contract test. It would hold on to an interface behind which was implemented by both the test double and the provider. And you would run the contract test once against the test double and then once against the provider. The joy about having an interface here is that you can make it as narrow as you like. So therefore, if you depend on only a tiny fraction of the functionality that the provider offers, then you write a very narrow interface that offers that functionality. And now you can write your test double to satisfy that narrow functionality and then test the provider as well. So let's take a look at our first explicit contract. So this is in C#, public interface iRevenue provider, and there's one method in this interface, decimal get revenue int customer ID. So it's not very complicated, is it? Doesn't get much simpler than that, I guess. Decimal maybe is a bit edge casey, but never mind. We're trying to get revenue. What are the implicit contracts? Well, let's start with the question. What do you think the explicit contracts are here? Well, the explicit contract is you as a consumer are going to have to provide an integer customer ID. And also explicit is that the provider itself is going to return you a decimal that represents that revenue. I think that's pretty much all you can take explicitly from this. But what's the implicit contracts? What else do you need to know to use this properly? Just think about it for a minute. Possibly not a minute, possibly just a few seconds. So what happens if you pass in an invalid customer ID? What happens? What sort of return value are you expecting? Can you say anything about the magnitude of the return value? Might it be positive or negative? Can you have a negative revenue? We just don't know. There's a lot of things around outside of that explicit contract from the signature of the method that you need to think about. And there are more than what I've written here. For instance, if it's revenue, what currency is it going to be in? If a currency conversion is happening, what date did that happen? What exchange rate are we going to use? So there's quite a lot of things that, depending on your context, you might need to know beyond what you saw in that contract. So we've talked about now what the implicit or some of the implicit expectations are. So now let's write some contract tests to actually give us confidence that our test double and our provider behave identically when it comes to the implicit area of the contract. So again, C#, it's the same interface that we're looking at here, and we create a class, a revenue provider contract class, which has as a member a pointer or a reference to the iRevenue provider interface. So that could be your test double, or it could be your provider. Doesn't matter at the moment. And we have an abstract method called get revenue provider, which we'll see, which you'll see a little bit later on. It gets called during setup. So during setup, we get a revenue provider that can be used in the test. And then we're going to test with the test for the valid customer ID, and we're going to test with an invalid customer ID. So effectively, these tests are just saying, if you pass to the revenue provider a valid ID, well, we just expect it not to crash. That's all it's saying there. We're not expecting any exception to be thrown. Whereas the invalid customer ID test is saying that if we give it an invalid ID, we expect it to throw a customer ID exception. And so this test will fail if it throws any other sort of exception as well. So we are now extending the contract to say, when we pass in a invalid customer ID, we expect to be signaled through the throwing of a customer ID exception, rather than a negative revenue or some other way of signaling it in the logs, and so on and so forth. This is just one pair of tests that are in this contract, but there may be others around the amounts that are returned, how many decimal points it's returned to, etc., etc. But here we've seen that to get to this point, you've created an interface, you've begun to build a bit of a test platform, you've had to create tests, have setup calls, you've got to have both your provider and your test double implement the interface. It's quite a lot of boilerplate code that you've had to create as part of your contract testing strategy, if the hand rolling route is the one that you're going to go down. So traditional contract tests run the same test code against the production component and the test double. That's what we've seen through all the diagrams so far. And what I hope even this short amount of code gives you the feeling is that it's hard work, or at least onerous work to do if you have to do it by hand. So let's document the contract. Well, let's think about how contracts get documented anyway. Unilateral contracts are the sort of centralized ones which come out of large standard organizations, such as the Internet Engineering Forum or something like that. ISO and IEC also have standardization efforts. And the thing about unilateral contracts is that although there's a group of industry experts that sit on these committees and help writing the contracts, you and me as sort of small people in small organizations around and outside the organization don't really get much of an input. We have to take what they give us and hope that it works for us. Often it does, sometimes it doesn't. But the only sort of interaction you've got with a unilateral contract is you read the terms and conditions and you click agree, right? So when you're signing up for your mobile phone contract, you don't negotiate with Vodafone, okay? You look at that contract and you go, yeah, I can suck this up or not. And I would put the optional there because I'm pretty sure most of you haven't read your mobile phone contract. Consumer-driven contracts, however, are different. We'll talk about them in more detail later, but consumer-driven contracts are where the consumer says what their assumptions are about the areas of the interface that the areas of functionality that are being provided by the provider that they're interested in, and they document how they assume they behave. And therefore they are open and incomplete. They are incomplete because the consumer very rarely uses all of the functionality of the provider. So they're only going to document the areas of functionality that the consumer is interested in. And they're open because things change, right? So whereas the HTTP spec changes come in, maybe every 3 years or maybe longer, in the consumer-driven contract world, which typically better mirrors business processes, things change more frequently. So the contract that you wrote yesterday might have been correct, but at some point in the future, it may be incorrect and you have to renegotiate that with your provider. So then that begs the question of how does a consumer-driven contract get agreed between the consumer and the provider? Maybe you work for a small organization, maybe you work for a small co-located team for a small organization where you can just look across the desk to the provider person and say, hey, how's this supposed to work? This is increasingly unlikely. Even small organizations now generally distributed. If you're in a sort of larger organization, you may be in one of those lovely open plan offices where the consumer team and the provider team are on the same floor, but there are other sides. You maybe meet at a water cooler if you're lucky, or at the canteen, but maybe not. If you're on a different floor in the same building, you probably don't even know what they look like. You might pick up the phone, but actually research has shown that if you're more than 20 yards away or 20 meters away from another team, you're very unlikely to know them personally or communicate with them face to face. But the reality of today is this is more likely what it's like. You've got consumer teams all over the world, and maybe you've got a provider team somewhere in North America or in India or in the Caribbean or somewhere. And somehow you now have to coordinate between multiple consumer teams in multiple geographies, living in multiple cultures in different time zones, interacting with the provider team, and it begins to get quite challenging. So basically with a consumer-driven contract, you have to negotiate and document the contract. And the way we do this is by each consumer capturing their expectations in a separate contract document. Now, this document is what Pact facilitates, and we'll see this later on. The consumer shares their view of the contract with the provider, and so does every other consumer. So we have multiple consumers all giving the provider team their view of the contract. And now it's the job of the provider team to take all those contracts and check that they conform to what the the provider team is intending to deliver, and where they don't, to negotiate. With Pact, and indeed with other approaches, the provider can create a test suite that validates these obligations. So they take the contract from the consumer, and then they essentially run those contracts against the provider they're running to make sure that either they haven't misunderstood or the consumer hasn't misunderstood. And when a failure happens, as we said earlier on, that this is a signal that they need to communicate with each other. So what? You either have to accept what you're given, i.e. a unilateral contract, or you need to negotiate between producer and consumer. And we have to facilitate this in some way. Consumer-driven contracts work well within organizations, even globally distributed organizations, and automation, which Pact provides, eases the burden. But, and this is really essential, you still need to communicate between the consumer and the provider. This is not a recipe or an excuse for sticking your head in the sand, just going, I've written the contract test, that's the end of my my part of these negotiations. So why is this all important? So I've already simplified, I said we were just talking about one consumer, one provider. But if we think about a continuous integration pipeline where you check your code in and then it gets compiled, tested, unit tests, then some maybe testing and staging environment before going to production. There's quite a lot of changes that go along the line. There's quite a lot of context that differs between the CI check-in through to the staging environment through to the production environment. Here we're thinking about component A. We're going to see some more components later. And A1 is version 1 of the component A. A2 is version 2 of component A. A3, version 3 of component A, and so on. And so we check in a change to the CI pipeline, and it's maybe at version 3. That's fine. Now let's think about a consumer and a provider that equally mirror this, right? So we're trying to make sure that when version 3 of the consumer hits production, it's going to work with whatever is sitting in production at the time. So what sort of testing do we need to do of the collaboration between consumer C and consumer P? Well, you remember that we need to be able to deploy services or microservices independently if we don't want to reach a point of having a distributed monolith. So let's go back to the diagram. What testing do we need to do? Well, we probably need to test to make sure that component C3 will work with component P3. Now, we might be doing that with a test double and some contract testing when it's just in the checked-in stage of the CI pipeline. But by the time we get to staging and prod, we definitely need to make sure that the actual version of the consumer will work with the actual installed deployed version of the provider in that environment. So we need to test C2 against P2 and C1 against P1. But does this mean that we have to promote C2 and P2 into production in parallel at the same time? Well, if we did that, we'd be violating Beth's statement about individual deployment. So we also need to test with the version of the provider that's in the next stage of the pipeline. So before we can promote C2 to production, we don't just need to know that it works with P2, we need to be sure that it'll work with P1, because to deploy it independently means we don't have any dependency on what the provider team does around promotion. But the provider team also needs to deploy independently. So we have to also test with the version of the provider that's in the previous stage to give the provider confidence that they can promote independently. And this is only with one consumer and one provider. So what? Services have to be independently deployable if you want to get away from a distributed monolith. You've got many environments in your deployment pipeline. They're all different. And having many services leads for the need for many compatibility tests between components in those different environments. Which is where Pact comes to the rescue. Pact provides a mechanism, and this is just a quote from I think the Pact.io site. I should have given the link to it. Pact provides a mechanism for creating a contract between a service consumer and a service provider, and then providing the tools to validate that the consumer and provider adhere to the contract independently of each other. The workflow, I hope this is still up to date diagram from the docs, but basically what happens is you run your tests on your desktop by using the Pact DSL, which is a domain specific language, to write your unit tests. By running them, it actually generates a transcript essentially of the interactions, the assumed interactions between your consumer and the imagined provider. That contract is then shipped across to the provider team, and they can then replay that transcript against their component to make sure that it behaves in the way that you, the consumer, thought it ought to. There's a lot more detail there. Go check the Pact.io docs or watch all the other sessions of this wonderful jam-packed Pactober festival. The Pact DSL is pretty easy to get your head around. It's a fluent DSL. This one deals with the HTML aspect of it, and it talks about a request, and it talks about the verb with a query with headers. Will respond with. These are all domain terms that anyone working in the web sphere will understand. I've shown a JavaScript version here, but there are many other bindings available for the Pact DSL. And in fact, there I've gone to list some of them. And even if your development environment isn't one of these languages, you can either use adapters or create your own adapters for other languages and other unit test frameworks. Once Pact is used to run the unit tests and then interpret that DSL, it generates a Pact file. In this particular one, it's being shown as JSON, and it just talks about what the request was, what the response was. It gives you essentially a formalized recording of the communication between the consumer and the provider. So remember, when it's generated, the provider has been substituted for a test double created by Pact. When the provider team get given this Pact file, they will play back the request and check to make sure that the response that their provider gives is the response that's documented here in the Pact file. And the key points about Pact are, it's the consumer that creates the contracts, and they should be using the Pact DSL to do this. When the consumer tests are run, Pact creates a mock HTTP server if it is HTTP that you're testing, and creates a Pact file that contains the transcript of the communication over HTTP. Then the provider will use that Pact file to verify that it is in fact compatible with this consumer. And then finally at the bottom, there's a sort of gotcha, which turns out to be quite a big gotcha, but it's one that will be dealt with by other people, I hope, which is that the provider needs to be in a known test state. So you remember from the earlier, when I was doing the hand rolling, the contract test, we talked about a valid ID and an invalid ID. Well, for that sort of test for it to be possible for you to write that sort of test, you need the provider to actually be able to guarantee you that 10 is a valid ID and 99 is an invalid ID, for example. And therefore, you need to negotiate with the provider team so that they give you some known start points where you know what data is in the database, or you know what state the service is in. You may remember I've mentioned a number of times we'll be going through that the consumer in consumer-driven contract testing generates the contract and then passes it to the provider team. Well, any manual handover becomes problematic. Even if you're sending by email, you're putting in a shared network folder or anything like that. These are things that are manual, people forget, they do it at the wrong time, blah, blah, blah. So Pact then came along and went, hey, well, let's make this automatic. And they provide a Pact broker. So this is another service that's running either on your network or in the cloud. When the consumer CI runs the unit tests and runs Pact to generate the Pact files, it will publish the Pact files to the Pact broker. And then the provider, when they want to run their verification tests, they will pull down the latest Pact files from the Pact broker and run them against their provider component to make sure that they conform, that they comply. So that's really, this is a very simplified view of the interaction. It's a little bit more complicated, but the complications here are all really excellent complications because once your consumer CI has published the Pact files to the Pact broker, the provider doesn't have to manually go and say, oh, look, there's a new Pact. The Pact broker can issue a webhook call to tell the provider CI that, hey, there's a new contract. Can you please check to make sure that it's still compliant? And that will then kick off elements of the provider CI build to see whether it does work. And the results are then published back to the Pact broker, which can then be configured to notify the consumer. So it's all decoupled in the sense that the dependencies are well defined and they're separate, but there is interactions via webhooks, etc., facilitated by Pact broker, which is very cool. And that's just as well, because you remember that earlier diagram I showed you with just the consumer and a provider on it? Well, that's not very realistic, is it? You've got, I mean, here I'm down with components V, W, X, Y, and Z. And imagine we've got A through V that's not being shown on this diagram. If you can imagine having to try and do all of the interactions between every component that's dependent on against all the other components that it's dependent on, then the arrows between these components and the various stages of the pipeline, it would completely cover the screen and your brain would definitely explode. There is no way that you want to do that as a human. So what Pact broker does is it maintains a matrix for each consumer provider pair, and there will be many of these relationships. It records the result of every verification with the version number of the consumer and the version number of the provider that have been tested together. I'm showing integers here. More likely it's going to be a SHA from Git that identifies the consumer and provider version. But the verification result is very simple. It's only going to be success or fail. And that's good. That means that if you want to check whether it's okay to ship component V version 38 into production, well, all you have to do, or all the Pact infrastructure has to do, is go through the matrix, look for every component that either depends on V or is depended on by V, pull out the SHA of the version that you're looking to promote, and pull out the SHA of the versions that are deployed in the environment that is your target of your promotion, and then do a quick lookup into each of the tables to see whether there's a success or failure. And if they're all successful, then it means that you are quite confident, not totally confident, but quite confident that you can promote that component into that environment. The tool that does this for you automatically is called Can I Deploy, which is, there's not many tools that have such a well-formed name. I like it. So the key points of Pact broker, the Pacts are published by the consumer and to Pact broker. The Pacts are fetched from Pact broker by the provider. Once the provider has finished confirming or running those Pacts against its current implementation, the results will be stored in the matrix within Pact broker, and that matrix supports Can I Deploy, which in turn supports independent deployment of your component. Pact's free, and Pact provides a DSL, which makes the costs manageable. Can I Deploy makes it really easy and quick and cheap to do be confident in your deployments. But the, again, caveat at the bottom is the provider team will need to provide known test data states for this all to hang together. So our takeaways, all interactions are governed by contracts. Contracting testing is there to ensure that both components have the same expectations, consumer and the provider. Contract tests should be written during development by the developers. I found in teams that have adopted contract testing that it increases agility and confidence, because it gives you that ability to run fast feedback tests using test doubles without the cost, the fear that comes with thinking that the test double may have deviated from the actual contract implemented by the provider. It definitely reduces the need for integration tests, and therefore both of the previous things allow you to speed up your development practices. However, it's no substitute for communication, and it's not a QA or a separate teams activity. It's a development activity for the developers. And it does not replace all other forms of testing. Let's repeat that. It does not replace all other forms of testing. It just reduces your dependence on some of the least productive forms of testing. So, final thoughts. You got to do testing. Integration testing is expensive, but test doubles on their own can't be trusted unless you compare their behavior to the actual component they're substituting for. If you want a distributed monolith, then ignore everything I've talked about. And I'm afraid I've overrun, but there you go. Do we have any questions? Do we have time to do questions?
We've always got time for questions. So. Do we have any questions from our audience, Tia and Ahmed? And if not, I will throw one out there.
It's all quiet on YouTube. We have people watching on YouTube, but there haven't been any questions there.
Either entirely opaque or incredibly clear. Both of those will work.
It was absolutely fantastic. I really enjoyed the super.
So I've asked, sorry guys, so I've asked questions in the chat, not in the QA pop-up. I'm not too familiar with Pact Flow or Pact IO, but I was under the assumption that I can do any kind of testing, like JMeter, performance, load testing, just plug in the API or the library and go from there. So if we have a contract, let's say in performance testing, we have a contract of these many users, let's say 10,000 users doing some workflow for 1 hour, the system would return these kind of parameters. The CPU, what else? And the memory will behave in a certain manner, and the performance will behave in a certain manner. So I can get all the statistics from JMeter and other kind of tools, but as a dashboard or as a validation, I have to really dig in to find the answers. So I was thinking maybe this is the Pact Flow is something that can provide such a thing. So maybe I was mistaken. I'm having this back and forth with Yusuf, and he's been really helpful. So I will look into it. So we have a number of Selenium, JMeter, Cypress, and all kinds of things. We do have unit tests, which is PHP unit tests, but they don't provide too much value in the sense that we have diminishing returns on unit tests. You can have 10,000 unit tests, but the product doesn't work. Still, unit as it is at that level of unit testing, if you take unit test as a method level testing in terms of languages. So it's a broader kind of a discussion. What would Pact Flow bring to the table as far as overall, functional and non-functional tests are concerned? What's the value added? That's kind of what I was looking for. So I have to dig deeper, I guess.
Well, I mean, so I don't know what conversations you've had with Yusuf so far. Typically, I think contract testing is more naturally applicable in the functional areas rather than the non-functional areas. I also think, you were talking about unit tests not adding value. I'm a big a big proponent of the test automation pyramid. I think unit tests themselves should be behavioral, not method tests. They should be testing how a component works. Once you're sure that that component works in the way that you expect it to, then you want to make sure that it interacts with the other components. And at PHP level, it might be the module level, or it might be a class level, but you want to make sure that they interact correctly. That can be managed by contract testing. By the time you get to having PHP work with a database or a credit card supplier or another B2B component, now you've got to make sure that you're implementing that interface correctly, and that is also where contract testing helps. It's not, in my opinion, or at least in my experience, I've never used it to surface to create dashboards. It's a development tool that allows for effective decoupled development between teams within an organization, or maybe within a small set of organizations.
Do you have any kind of use cases? So I think it's beneficial to talk about use cases in terms of developmental testing. So any accessibility 508 or things of that nature?
So I think Ahmed, some of those other tools. So first off, I'd probably recommend reading the docs.pact.io website first. That'll give you a bit more of a fuller idea as to the capabilities of Pact. So what Pact is it's not a functional testing tool, it's not an accessibility tool. Now, every test is a contract, but maybe not every, when we're talking about contract tests here, we're not kind of talking about every type of test. So you mentioned that you have kind of JMeter tests that perform your functional testing, your non-functional, so your performance testing, and there's results there and you don't have a good way of surfacing that. So that one sounds like a problem for your performance testing tool and its reporting capabilities, but maybe, and other people have suggested this, that at the moment Pact supports Pact contracts and has a matrix which allows you to validate the relationships between those. We've been asked before if Pact could support other contract types. So if you imagine you have this performance test that's been conducted between two sets of applications, for example, and you have a contract and then you test it, you've got a result from that contract. Effectively, you could upload those to the Pact broker, but you're kind of working outside of the recommended flow. So we have had questions of how do I use my existing kind of contract I've got between systems and then use the capabilities of the Pact matrix. So the kind of quick answer to that is the capabilities you're requesting don't exist. If you wish to request some of those capabilities, I would 100% say drop onto the Canny, canny.pact.io, so our feature request board, where you can drop your particular feature request. You can go into as much detail as you wish, and we can see if there's appetite from the community or other people have other solutions they can share. But maybe Pact isn't the particular tool you're looking at to solve that problem, but definitely there's people who are quality and testing related who'd be happy to continue that conversation with you, probably offline, if that's okay.
Oh, excellent, thanks.
My pleasure, and thanks for the question as well. If you do wish to know more about Pact, we will be running some workshops tomorrow. So at the same time, 3 p.m. BST, we'll be running 4 of them throughout the month. So hopefully by the end of the month, you'll have a really full idea as to Pact's capabilities and limitations.
All right, thanks, appreciate it.
My pleasure. Do we potentially have any other questions, Tom? If not, thank you very much, Seb, for your wonderful, enlightening talk. It's always a pleasure to hear from you. Can see some lovely reactions from people. We've had a fair few join us through on the YouTube as well. So if you want to find out more from Seb, you can see any of his social handles here. I would wholly recommend checking out his books on behavior-driven development, BDD books at bddbooks.com. And you guys and girls can reach us in the slack.pact.io, where you can find us in the Pactober channel all month. So thank you very much, sir.
Thanks, Yusuf. Bye bye.
Thanks, Yusuf. Thanks, Sam.
Take care all. Thank you. Bye.